And if we finish a little early, then they can have a little break before the next one. So, okay, we'll go ahead and get started here. How do I? Sorry, I'm trying to get to that tab where, there it is. Let me get up to the top here. Okay, sorry about that. We'll go ahead and get started. Okay, can everyone see that okay? We're good?
Yep.
Okay, so let's go ahead and get started. Good morning, everyone, and welcome to your, what is this, your second or third review session. Today we're going to be covering the first topic, which is atmosphere and pollution, and then the second topic is going to be legislation and ethics. And so I'm your first presenter. My name is Sara Nolen. I teach on the western side of Kentucky, so I'm in Henderson County today. So I've been teaching AP Environmental Science for a couple years now. Love it. Can't say, you know, it's definitely the best class there is. So if you're enrolled, so, but just a little bit about the presenters here. Again, you know, this is part of the Advanced Kentucky. And again, just kind of a little disclaimer here for you. Here's where you can find information about Advanced Kentucky, Twitter and Facebook. And then if you would like email for the director, that is also provided here as well. And don't forget, all of this is recorded and will be uploaded. So if you would need to go back and review any of this at any time, then you can on your own. So meeting etiquette, we'll go ahead and cover that. Looks like microphones are off and video is off. As far as chat goes, we will be using the chat box today. And when I'm presenting, I can't necessarily see everything in the chat, but my co-host today will be helping me out with that. So, you know, feel free to throw something out in the chat box if you have a question or, you know, if you want to comment on something, then I'll definitely be utilizing that. Okay. Okay, so let's go ahead and get started since you're here, and we'll get going on our way. I know kind of the course of the timing of the course. Many of you have maybe started atmosphere and air pollution. Maybe you're about to start it. So for some of you, this may be a review. For some of you, this may be totally new, but that's okay. So basically what I'm going to do is I'm going to go over the main topics that College Board has outlined of stuff that you need to know. And then after each one, we'll do a little multiple choice practice. And if it's always good to practice those, even if you don't have all of the content under your belt yet, just to do some test taking strategies with that as well. Okay. Okay, so let's go ahead and get started. So, you know, the atmosphere is one of the resources that you've learned about in this class. You know, we've talked about water and we've talked about land. And so this unit 7, covers the atmosphere that we use. The layers of the atmosphere has been covered. You may have touched on that back in unit 4. And so what we're going to do is we're going to revisit the atmosphere as a resource, but we're going to talk about the pollution that is in that resource, in the air that we breathe. And so the technical definition of pollution is any chemical, particulate matter, microorganisms that are high enough to harm plants, animals such as ourselves, materials such as buildings, ecosystems. And so we're going to look at a variety of chemicals, dust, smoke, particulate matter. And when we get to indoor air pollution, we'll even talk about the microorganisms that can affect our health. Okay. Okay, one thing you need to know about air pollution is that it can be a primary or a secondary pollutant. So some of the air pollutants that we're going to talk about today are primary pollutants. Those are, you know, kind of dangerous enough by themselves. Those are the ones that are emitted most of the time from burning of fossil fuels. You'll see fossil fuels pop up over and over and over as we talk about these. These are the ones that may come from natural sources. They may come from mobile sources. They may come from these stationary sources. And then when these primary pollutants that we're going to discuss today come into contact with other pollutants or water or sunlight, they kind of make what I call a chemical cocktail. So they start bonding with each other, and now their chemical composition changes, and now we call them secondary pollutants. But remember, secondary pollutants would not exist if it wasn't for the primary pollutants to begin with. So many of the primary pollutants that we're going to talk about today, not only do they have their own effects, then they may also move on to become secondary pollutants and have additional ecosystem and health effects. Okay, so let's talk about where these, where the air pollution comes from. And what I'm doing in our presentation today is that if you see one of these bullet points, this is the straight from the College Board course and exam description. And so these are kind of like the bare minimum, what you need to know. And so I'm going to go through each of those and then kind of elaborate on each of them. Okay, so air pollution comes in comes from natural sources and anthropogenic sources. And so there's a variety of natural sources of things like particulate matter. That might be the ash, the dust. Carbon dioxide is also considered one of those air pollutants that is also a natural air pollutant. It may come from, respiration, decomposition, volcanic eruptions. So a lot of times when we think of air pollution, we think of those anthropogenic sources, but we can't forget about those natural sources of air pollution. Because as we study air pollution, I always tell my students, there's basically three things that you need to be able to do with the pollutants. And pollution is going to be a very large part of your exam. And so once we get to this point, up to this point, I've kind of let my kids use the word pollution, but up until this point, now that we're going through the pollutants, I really think it's important that you start to know them specifically and individually, and that you can individually come up with the name of the pollutant, the source, so where is it coming from, whether it be natural or anthropogenic, the effects, so the consequences, and then the solutions, because part of this class is looking at solutions. So it's not so doom and gloom. It's, what can we do about it? Okay, so air pollution, some of those sources we're going to look at today are going to be natural. Many of them, though, are going to be those anthropogenic that are coming from fossil fuels. So we're going to look at things like carbon dioxide and sulfur dioxide and nitrogen oxides and carbon monoxides, hydrocarbons, particulate matter. And so looking at those fossil fuels is a big source of that anthropogenic or that human-made source of air pollution. Which brings us to the question, well, why fossil fuels? Why are we going to see fossil fuels pop up over and over and over in today's presentation and in today's sources of air pollution? Well, you got to look at the chemistry of it, okay? So you got to think fossil fuels, what's in fossil fuels used to be alive. And so you have to think about the main elements of living things. And so now we're tying in some of those biogeochemical cycles that we all know and love. And so the main elements, like the carbon and the nitrogen and the sulfur, were in those living things long before they became the fossil fuels that we are now digging up from underground. So when you connect those things to fossil fuels, knowing that fossil fuels are going to have carbon, because the living things that made up the fossil fuels just have carbon and nitrogen and sulfur. And then what do we do with fossil fuels? Well, we burn them. And then when you burn them and you go through combustion, you're going to add the oxygen element to it. So this is kind of the chemistry behind why fossil fuels keep popping up so often in our sources of air pollution. This is why we have carbon monoxide, because when you burn the fossil fuel, you get the carbon and the oxygen. Same thing with carbon dioxide, or the nitric oxide, or the nitrogen dioxide, or the sulfur dioxide. Also, as we go through these air pollutants, you're going to notice that some of them have these things called the criterion pollutants. These are the ones that are monitored by the EPA. And so in your kind of little, topic 1 introduction to air pollutants, the good news is that yes, we have air pollution, but the good news is, thanks to the Clean Air Act and the Environmental Protection Agency, certain chemicals, especially like lead and some of these other pollutants that you see down here, have decreased. And that is because these are closely monitored through industry by the EPA and the Clean Air Act. So even though the population has gone up and energy consumption has gone up and we drive more and we are industrializing the world more, you can see that these air pollutants have gone down. And so these are the ones that are monitored by the EPA. Now, some of the other ones that we're talking about are not on this list. And so there, you don't necessarily have that same trend and data from what it was before 1970 to afterwards. Okay, so just another little support that yes, these regulations, kind of what we're going to talk about in the next session, really do end up helping with those environmental issues. Okay, so let's go ahead and get started going through the those pollutants that you just saw on that graph, the ones that are monitored by the EPA or maybe may not be monitored by the EPA, but especially ones that are coming from those fossil fuels. So the first one we're going to cover is sulfur dioxide. And so what I have my students do is I have them come up with a little chart. Sometimes they make flashcards out of it. And I make sure that they, like I said, know the source. So in this case, where do we get sulfur dioxide? Well, there's natural sources of volcanoes, but it also comes from coal and oil. I have them know the effects. When in doubt, for all these air pollutants, you can always throw out respiratory irritants because most of the time that will definitely give you the point. Most of these do cause some sort of respiratory irritant, or we wouldn't be talking about it in the air pollution unit. Sulfur dioxide can go on to become a secondary pollutant and can lead to acid rain. And then I want them to know the solutions because this is also part of it. This is actually a main topic in there too in your outline. But I go ahead and make them learn it as they go. So as you are, studying these air pollutants, that's something to kind of keep in mind throughout this next unit. So what can we do to decrease levels of sulfur dioxide? Scrubbers and burn low sulfur fuel. When in doubt, also you can always put in a solution, maybe use less fossil fuels or renewable energy or conserve. That also would be a good solution to decreasing that air pollutant. Another one, nitrogen oxides. This one mostly comes from transportation. Again, there's that respiratory irritant, and this one too can also go on to lead to acid rain. And this one also plays a role in ozone formation. So because the EPA realized that it had such a role in so many of these secondary solutions or secondary pollutants, that's why it is monitored. And so solutions, because we had to obviously decrease it, in your cars, now have catalytic converters. And then again, there's that find alternatives to fossil fuel solution. Particulate matter is another one that comes from the burning of fossil fuels. This is also natural in terms of dust or ash. Why does it matter? Why should we worry about particulate matter? It isn't, there again, respiratory irritant, reduces visibility. And so how can we combat that? There are filters, there are electrostatic precipitators that can be used at those coal burning power plants. And again, there's always finding that alternative energy besides fossil fuels. And one thing you need to make note of the particulate matter is that the smaller the particles, the more of effect it's going to have on you. And why is that? It's because it's more likely to get into your body. We have our own natural defense mechanisms like the nose hair, the phlegm that's supposed to trap all that particulate matter. But the smaller it is, the more likely it is to kind of slide right on through those defense mechanisms and then settle in your lungs. Carbon monoxide is another one that was addressed on that graph. This one comes from auto exhaust and incomplete combustion. Why do we need to worry about it? It binds to your hemoglobin, reduces blood's ability to carry oxygen, and there's that catalytic converter solution again. And also,
hey, Sara.
Yes.
Hey, take a second and maybe ask the question to the chat room here, because there was a question was popped up while you were talking, and it was basically kind of like could you clarify what primary pollutant versus secondary pollutant? And I was typing some stuff while you were talking, but let's take a second maybe and ask the kids, is carbon monoxide in this example here on this slide, is that considered primary or secondary? And have them go over to the chat room and see if they can tell us which one it is.
Okay, well, yeah, let's go ahead and do that, kids. So things that I've been talking about so far, like you said, carbon monoxide. Why don't you kind of go over to the chat box, kind of throw out some ideas there if you think it's primary or secondary.
All right, so I see a secondary already. Primary. All right, Sarah,
Okay.
go ahead and
Yeah, I'll
take
go ahead and
it.
discuss that.
Yeah.
Carbon monoxide. Okay, I'll kind of give you a hint, guys. Up to this point, what I've been talking about are primary pollutants. These are ones that by themselves have their own side effects. They have not mixed with other chemicals in the atmosphere yet. They have not combined with water yet. Sunlight has not had an effect on them yet. So these are primary. And so, like I said, primary are ones that are directly coming from, let's say, burning of the fossil fuels. My next topic, so as soon as I finish this one, then we'll get into the secondary. The two major secondary ones would be like acid rain, tropospheric ozone. And so we'll get into that a little bit later in the session. So what I'm covering now are the primary ones that can eventually become secondary, but these you need to know just as the primary. Like these are the ones that on their own can cause harm, but some of them eventually can go on to mix and cause more harm. Does that kind of clarify things?
And you guys can say something in the chat room if that, yes, that does, no, it doesn't, that kind of thing.
Okay, so then let me go kind of ahead and finish up the primary ones. And then once we get to the secondary ones, then it might make a little more sense. That might help kind of clarify things as well, I think.
Yeah.
Because like I said, if you really haven't gotten too far into air pollution, then obviously I can completely see why this would be, kind of a big question here. But I think once I cover the secondary, then it might clarify it a little bit more. Okay. Okay, so then we'll go ahead and move on then. We got about two more primary to cover, and then we'll, like I said, we'll move on to secondary. Okay, so lead is another one that is monitored by the EPA. This is another primary one. It used to be added to gasoline. Now, in some developing countries, I think they might still use it, but I know in the United States, it was starting to be phased out in 1975, and that's why when you pull up to the gas station right now, you see this unleaded sign here. The reason why we phased it out is because it is linked to nervous system disorders, learning disabilities. You can kind of see from this chart here, I know it's kind of small, but there's lots of effects it has on the entire body. And lead is one of those primary pollutants that you're going to hear about multiple times. You're going to hear it in your air pollution unit. You're going to hear about it in your water pollution unit. You're going to hear about it in your soil pollution unit. So you're going to hear lead a lot probably over the next couple of months moving up into that exam. But as far as air goes, they used to put it in gasoline, and then, through deposition, then it would end up in the soil as well. It can be an indoor pollutant as well as an outdoor pollutant. So lead is one of those kind of crosses over into several areas there. But it is dramatically, decreased in the atmosphere because we started to phase it out in 1975. Okay. And then one more that is in fossil fuels that is not currently monitored by the EPA in terms of, I'm not saying it's not monitored. Maybe I should rephrase that. Yes, there are, levels that are tracked, but you can't necessarily get fined for having higher levels. Maybe I need to clarify that there, okay? So mercury. Mercury, as an example, like in burning coal, it is toxic to the nervous system, and this is one that will pop up in your water pollution unit. So as you get into water pollution in the next month or two, and you review things like bioaccumulation and biomagnification, this will pop back up as well. But you need to cover it in the atmosphere pollution unit because it does come from the burning of coal, and it gets into the air, and then through deposition, through the deposited and rain and snow, then it can also show up in your water pollution as well. And then there's your solutions. There it is kind of again, alternatives to fossil fuels, burn less coal. Okay. So let's kind of pause here for a minute before we go on to the secondary ones, kind of do a little check real quick, see how you're doing. Let's go ahead and start here. So, and you can throw out your answer in the chat box, and then I'll go through the answer, and then we'll kind of move through a few, and then we'll go on to the secondary pollutants, okay? Okay, so this one wasn't specifically covered in today's lecture, but it is important to know and it's important to review. And this kind of ties in those, atmosphere as a resource. So when we're talking about the atmosphere as a resource and we're talking about the majority of pollutants, where are we talking about here? Are we talking about the troposphere, the stratosphere, the mesosphere, the thermosphere, or the exosphere?
So go ahead and give us your answer in the chat room. What do you think? What's the answer?
And then I'll give you the answer. We ready?
Yeah, we're getting troposphere.
Okay. Troposphere, yes. Very good. Troposphere is where we're talking about here. Now, as you get further into, let's say Unit 9, you're going to talk a little bit more about the stratosphere. But today, what we're talking about is troposphere. This is also where your weather events happen. This is also where, when you talk about climate change, it's also happening all down here in the troposphere. Okay. Okay, this one I think we should be able to do. All of these have declined since 1970, except particulate matter, sulfur dioxide, ground level ozone, nitrogen dioxide, or carbon dioxide. Do you remember which one we didn't really talk about yet? Okay, so on this one, if you have guessed E is the correct answer. Carbon dioxide is not one that has declined since 1970. In fact, it's the opposite. What has happened to carbon dioxide since 1970? It has gone up. And so that is why when you get to climate change and you get to solutions for climate change, one of those solutions might be, monitoring carbon dioxide or doing a carbon tax or doing some sort of limits on carbon dioxide, just like how the EPA has done for A, B, C, and D. And it is shown that those levels have gone down. Okay, one more here, and then we'll try secondary pollutants. Which of the following are direct products of the use of fossil fuels in automobile engines? So look through this list and think about which ones we talked about in those fossil fuels. Now, even if we didn't talk about all of them, this is also a good test taking strategy, because think about which ones we have talked about coming out of that exhaust pipe when we're burning those fossil fuels. And so again, this one, I threw this one in here because even though I didn't talk about all of them yet, I wanted to kind of highlight this would be a good one to practice those test taking strategies where you look for the best answer and cross your fingers and hope for the best and move on to the next question. So which one here have I spent the most time talking about in the last couple of minutes? What are most of the answers?
It's crickets right now.
Is it? Okay.
Yeah. All right, guys. One thing I'll tell you, when you see car emissions, automobile emissions, or whatever, that there's really just one of them on here that's almost 100%, car emissions. All right.
Guys, if you're wrong. And to be honest with you, I can't even see your answers right now, so I don't even know if you're right or wrong. So
we got D was a guess.
D, okay, I can see D. We did talk about carbon dioxide. We're getting close. C has carbon dioxide, D has carbon dioxide, but let's look at E. Okay, so going back to what I covered, we don't really have that lead coming out of the automobile engines anymore. Like they phased that out. So I could see that because of the carbon dioxide. But this one right here, especially that I made a point to kind of note when we were on the NOx one, that most of that does come from exhaust. And that's when we talked about the catalytic converters. Now, in your defense, I have not talked about VOX yet. I was saving that when we got to ozone because that plays a major role in ozone. But this, I realized we haven't talked about, but E right here would be the best answer. Okay, and so this is one of those practice problems where, like I said, maybe we didn't cover all of them. And so as you're taking the test, you might come up with a question like this where you're like, oh, I don't remember my teacher talking about all of them, but at least if you remember 2 out of the 3, this is a good one to, like I said, to practice with. Okay. Okay, so those were some of the primary pollutants. Okay. Now what I'm going to do is I'm going to go into the secondary pollutants. And so maybe this will kind of help clarify some of the differences between the primary pollutants and the secondary pollutants. So in the first little topic, we talked about some of those primary pollutants, and NOx was one of those primary pollutants that we're going to kind of come back and now highlight and talk about, okay, well, what can that do? And so you might have heard about smog before, or tropospheric ozone. And so ozone kind of comes in, there's a phrase, ozone is good up high, but bad nearby. So we're talking about the bad nearby tropospheric ozone, which also known as photochemical smog. And so this happens when the nitrogen oxides, so where were the nitrogen oxides coming from? They are coming from the burning of the fossil fuels. Okay, really emphasizing in this car here, which is just like our last question. And volatile organic hydrocarbons, so these are the VOCs that I'm going to talk about, react with heat and sunlight to produce a variety of pollutants. So this is a secondary. How do I know it's secondary? Because it's almost like a little, it's going to be like a little math equation at this point. It's going to be like this plus this gives you that. And so when we start adding these things together, that's how we get those secondary pollutants. Okay. So VOCs, let's go ahead and talk about that really quickly. Volatile organic compounds can be things like formaldehyde, gasoline, so there's that fossil fuel again. Those are things that kind of give off those fumes. And so they can be in building materials, they can be in home and personal products. There's a list here for you. They can be in fuels and machinery. And so these play a major role in forming some of those secondary pollutants like tropospheric ozone. Trees can even be a natural source of them. So by themselves, they're not, yes, they're harmful to human health, you know, especially kind of they give you that headache, you know, basically any of those symptoms that you get from, you know, the fumes. But the problem with VOCs is that they lead to that, the ground level ozone. And so look at this little graphic here. This kind of explains how it happens. And so maybe now this might clarify what I mean by secondary pollutants. So you have these NOx and these VOCs that are coming out early in the day. Well, as the day goes on, we get more sunlight. And with the sunlight, then what happens is that we end up getting this ozone, this O3. And so the ozone is produced because of that chemical reaction. So when you see the words chemical reaction, or you see something react, or you see a culminating event, that's basically how you're going to know it's going to be a secondary pollutant. So how can we reduce that? Well, it all goes back to the source. And so that's why I think it's so critical that you know those sources. And so if you can reduce VOCs and NOx at the source, then you can reduce the secondary pollutants. You know, like just like if we wanted to reduce acid rain, you have to reduce it back at the primary pollutant. So these primary pollutants, the VOCs and the NOx, I call them my Dr. Seuss pollutants. You got the VOCs, the NOx, the SOx. As day goes on and we're driving more and we're burning more fossil fuels and it's sunnier, then we have that ozone that is the end product of it. Okay. So why don't we want the bad nearby ozone? Now up high, it's good. I mean, that's part of our, the stratospheric ozone layer, but nearby, it's still the same chemical formula, O3, because it can harm human health in several ways. And there's different levels. And so you might have heard this, during the summer, sometimes they call them the no zone days, or you kind of know what the ozone levels are high. And they encourage people with breathing difficulties, emphysema, asthma, the elderly to kind of avoid outdoor activity or outdoor exertion, children, older adults, because of the difficulty that they may have with respiratory problems. Okay. You're going to find more of these ozone days in urban areas because cities bring more cars, and in sunny areas. So places like Mexico City, LA, are going to have more ozone days than some of those other areas. We have a lot of ozone days here where you live, just because, we have the cars and we have the burning of the fossil fuels. And so, during the summer, it's not uncommon to have a high ozone level day. Okay. Okay, so let's kind of I know I kind of went through that kind of quickly, but it's always good to get some multiple choice practice in. So let's just try one or two. Let's kind of see what you kind of picked up there about ozone, and then we'll move on. Okay, so although ozone in the stratosphere has been decreasing in recent years, ozone near Earth's surface is on the increase. So that's kind of that bad nearby ozone. And so why is this undesirable? So I think this one might be a little easy one to kind of get you some confidence here. What did I say? Always look for. When in doubt, you can always use this phrase here when we're talking about air pollution. And I see it on here.
Seeing D's.
Okay, good job, guys. Building up some confidence there. So lots of D's. Yes, it is a respiratory irritant. So that's why I said, when in doubt, go with respiratory irritant. Okay. And this is the secondary. So what is the primary? Primarily comes from, now this one's kind of a 50-50 here, if I had to guess what you're going to guess. But think about places like LA and what I mentioned about what places those big cities have more of. And if you are guessing E,
E's.
very good. E is the correct answer here. Okay. Good job. Okay, moving right on along then. So sometimes you might end up with a thermal inversion when we're talking about air pollution. And so thermal inversion basically just means that there is this blanket of warm air that is trapping the air pollutants down below it. And so on those high ozone alert days, or, especially smog and particulates, it kind of just traps the air underneath. So this is a good topic to cover right after you have talked about tropospheric ozone. Because in some of these, especially the sunnier cities that might be surrounded by mountainside, they have lots of cars, they have lots of sun, and then basically based off of the geography of the area, they may also have the mountains around them that will sometimes lead to these thermal inversions. And when that's the case, you're basically just kind of trapped under this blanket, and it just kind of keeps circulating down here. Okay, so let's look at what kind of area might have a thermal inversion that might enhance a photochemical smog event. So are we thinking New York, LA, Portland, Atlanta, or Philadelphia? And so think about what you need to have smog and ozone, and which one of those is going to have really high levels. So what's our main guess?
We're seeing B, A.
Okay, guys, think sun. Sunny California. Sunny California is going to have high levels of smog because of those thermal inversions. Okay. And again, and as you learn this material, you'll get better at it. And I think a lot of it is, you may not have had a lot of this in class yet. And as we cover this in class, you will be ahead of the curve because, you've had it before a lot of your classmates have been. So to think of this as like a good little introduction. Okay. Kind of moving on along here, let's move on to another secondary pollutant known as acid rain. Now, you don't have acid rain unless you have those primary pollutants first. So that's why it's important to cover those primary pollutants before we get into the secondary pollutants. And so the primary pollutants responsible for acid rain are the nitrogen oxides and the sulfur oxides. And where do those come from? Well, you can kind of see from this graphic here, or you might remember those are coming from the burning of the fossil fuels. And then when these two culprits here get up into the atmosphere and they find water, then they will now form sulfuric acid. So you can see the H and the S and the O. So there's the S and the O. Where'd the H come from? Well, that was the H2O. And so now they're causing sulfuric acid. Same thing with nitric acid. And then that is how you get acid rain. So again, I know it's a secondary pollutant because it had these little primary pollutant culprits over here. And so when they get together in the atmosphere with water, now we're going to have acid rain. Okay, now acid rain is one of those topics that I feel like, with my own students, I spend a little bit more time with than I do, some of the primary pollutants, because with the primary pollutants, it really is just kind of a sit and get and a memorize. Once we get to the secondary pollutants, there's a another slew of consequences you got to kind of understand, and some more chemistry in there. Okay, so where does acid rain come from? Well, like what we said, the burning of the fossil fuels. So if you are a community that is downwind from those coal burning power plants, then you're going to typically have higher acid rain levels than areas that are not either burning coal or not downwind from it. And so what happens is that these areas here, this is a large area that does in fact burn coal, but then you also have to think the wind that is blowing the SOx and the NOx into the atmosphere is going to have some of the higher levels of acid rain in this area here. So that's kind of why you have those differences there in the country. Okay, now when we're talking acid rain, I don't want you to think that there is just battery acid falling from the sky. Okay, like that. It's not. A lot of people think it's a very dramatic event, and that everything's just going to die, and you're just going to walk outside, and your clothes are just going to be, just dissolving from acid rain. You've got to drop the drama when it comes to acid rain. Yes, it is a detrimental environmental impact. Absolutely, it absolutely is. But the biggest mistake that students make, that I've always noticed with acid rain, is they think it's just the worst case scenario. So you have to, one, understand a little bit of chemistry and understand the pH scale, and that 7 being neutral, that just rainwater by itself, you can see here, just rainwater by itself is already a little more on the acidic side. Okay, so these are the acids, these are the bases. And so rainwater itself is already slightly acidic. So when we're talking acid rain, we're not talking down here, okay? We're just talking just a little bit lower pH here, about a 4 typically. And so why does this matter? Well, it matters for living things because you can see these are the pH levels where these living things are laying their eggs and thriving best in. But it's not going to just dramatically just kill off all of these living things. They may struggle, okay? They're definitely, especially when we're talking about range of tolerance, but it's not going to be a dramatic die-off event. What's really going to happen, it's going to happen more from the soil aspect. And that's what I have a really hard time getting my students understand, that it's not the acid rain falling from the sky itself that's going to hurt the organisms. Now, it might hurt the building material, but it becomes part of the ground, and then it starts messing with the soil chemistry. And that is where we're going to have detrimental issues, okay? So it can acidify the soil and bodies of water, like what we talked about in the previous slide. So it can acidify the water to where these organisms have a hard time, especially with their egg and their young development. But when we're looking at the soil, what happens is that it starts to leach some of those nutrients from the topsoil, and the soil chemistry is changed. And really, we're looking at key things like aluminum. And some of those metal ions are converted into soluble forms, and that's when we start to have problems. So it's not a dramatic die-off event. It's basically a chain of events. And so a lot of times it starts with the soil, or, it can affect like the needles on the trees. It can affect the plant's ability to withstand cold temperatures, again, because it comes down to the chemistry of it, okay? So looking at the chemistry of it, you got to have a little chemistry background to understand a little bit more of the acid rain. And if I'm not mistaken, I think your last FRQ, your mock FRQ is over acid rain. So I'm hoping that your teachers have kind of spent some time going over some of those detrimental effects of acid rain with you, okay? Okay, so like I said, kind of removing the drama from acid rain, let's practice some of those multiple choice problems here, okay? So why would a scientist think that an area was experiencing acid rain? Okay, so actually I'm going to go through this one with you, and so if you want to guess in the chat box, go for it, but I'm going to kind of go through how we would find the best answer here. So A would not be the best one because it's not going to be a sudden die off of all the fish. Like I just said, it's not going to be a dramatic event. We did not talk about anything about temperature. We have not talked about anything about photosynthesis, and an increased rate of photosynthesis actually kind of sounds like a good thing, okay? A long-term increase of pH might be one that students start to guess on because they're like, oh, we did talk about pH, but we aren't increasing the pH. We actually decrease the pH. So again, emphasis on those soluble heavy metals. This is why E would be the best answer, okay? Okay, now 2, I do want you to try. So throw this out in the chat box. Let's get a little participation here. Make sure you're still with me and awake and all of that on this Saturday. I don't know where it is on your part of the state, but it's a pretty gloomy, rainy day over here. Okay, so acid deposition would most likely result in which of the following? So why don't you guys try this one since I kind of helped you with the first one?
Starting to see A.
Very good. You guys picked up on that and the aluminum. So yes, A definitely is the best answer. Good job, guys. Okay, and then let's see if you can do one more, and then we'll cover a few more things in air pollution and wrap it up. So which of the following would be an effect? And so think about what I talked about with the forest.
Seeing B.
It's in B. Okay. And again, guys, this is a chemistry thing. So it's actually going to increase the concentration of hydrogen ions. So actually A here would be your best answer. And that kind of goes back to, I'll kind of go back here a little bit. They have a decreased cold tolerance because, like I said, that changing of the chemistry of the soil and what the needles are able to withstand. Okay. And if you missed that one, that was a one in years past has kind of been a difficult one to get. But like I said, I wanted to challenge you this morning and see if you could pick that one out there. Okay, so moving on, again, really quickly, I'm going to kind of finish this up soon to kind of get you the material and then kind of wrap things up so you can have a little break before your next session. Okay, so indoor air pollution. So everything I've covered to this point has been about outside. Guys, inside is probably worse. Inside is just as bad as or worse for you. The good thing about the outside is that we got wind patterns and we can kind of aerate and that we have EPA regulations. Inside, you're kind of stuck with it. And most of the time you're trapped inside with it. So if you have poor ventilation, especially in places like developing countries where they are burning so much inside their house for heating purposes or for cooking food purposes, then you're going to end up with some of these things that I've highlighted here. And again, I'm not going to read all of this to you, but some major ones that we definitely need to make note of would be things like radon, VOX, formaldehyde, lead coming from inside, you know, if you have an older home with lead paint, carbon monoxide, there's that primary pollutant again coming that can come into your home, especially with things like faulty furnaces, that incomplete combustion. Tobacco smoke, you have the microorganisms like the mold, these are ones that, like I said, we're trapped inside with. So what can we do? Well, we can aerate our homes. Plants, indoor plants are, you know, some of the best air filters that you can get. And so these are kind of things we kind of need to keep an eye on because this is what you are more surrounded with on a daily basis that can lead to health impacts, okay? Radon, especially, is one that you need to know about. This one always pops up on the exam. This is one that you'll actually, you know, we talk about this class can't get any more real world. You know, I bought a home last summer and they always ask, do you want to have a radon test conducted? And so because it is the second leading cause of lung cancer in the United States today, radon has kind of become a hot topic in the buying and selling of houses and making sure that you're not getting high levels of radon coming into your home. Because underneath your home, there is bedrock. And if there is uranium in that bedrock, then as the radioactive gas radon can then seep into your homes. Okay, how do you alleviate that? Well, it's all about, making sure you have proper ventilation and you can actually, mitigate that. Carbon monoxide is another one you need to worry about in your homes. This is one that, like I said, it causes the hemoglobin not to pick up the oxygen, and you can die of carbon monoxide poisoning. This is, happens with cars running in the garage. I just read an article about people, forgetting to turn their cars off now that we have this push start. And, they find people unresponsive in their homes. This is one that if you are, running a generator inside your home, any of the burning of the fossil fuels inside your home can definitely lead to that carbon monoxide poisoning. Old furnaces, natural gas heating can lead to high levels of carbon monoxide. Okay, I'm going to kind of skip through the multiple choice really quickly and make sure I cover all the topics with you. And then if we have a little bit of time, then we'll come back to the multiple choice. Okay. Because there's two more that I wanted to cover with you. And then, like I said, whatever time's left over, we'll kind of pick up on some of that practice. Okay, also in Unit 7 is noise pollution, which we don't always think about in terms of air pollution, but you have to think it is a pollution in our atmosphere, whether it be our indoor atmosphere or our outdoor atmosphere. Noise pollution is one that, especially over a long term, can lead to physiological stress and hearing loss. It comes from all over the place, outside, inside. It has ecological damage. When we're talking about whales and we're talking about, their patterns, their migration patterns, and if they can hear each other. And so some of that underground drilling has a lot to do with that. So yes, I realize I'm getting into water pollution and not so much air pollution. But this is a lot of these pollutions, guys, you're going to find, kind of crossing the barrier of atmosphere and water. Okay. Now this one, I think you could probably answer. We get some confidence here. Of the following, which is true of noise pollution? Why are we worried about noise pollution here?
I'm not hearing anything on the chat room, but
well, maybe I've been noise pollution for them for the last 47 minutes.
Oh, we're seeing D.
Okay, so we got some D there. Okay, sudden or persistent noise may lead to permanent hearing loss. So that's why we are concerned about noise pollution on a human and environmental impact there. Okay, and then the very last topic, then we'll kind of wrap things up. Reduction of air pollutants. So I feel like throughout the presentation, I tried to hit on solutions for each one, but kind of wrapping it all up. Remember, in every topic that you talk about in this class, we always have to look for solutions. So instead of the doom and gloom and, let's look at innovations, let's look at technologies, look at solutions. So obviously you can always use the go-to solution, use less, conserve alternative fuels. But then realistically, we also have to think about, we are in a fossil fuel world. So how can we decrease those air pollutants while still burning fossil fuels? And so you can have vapor recovery nozzles. That's what helps with the VOx, so we don't have as much tropospheric ozone. Catalytic converters, we talked about that with the cars, and that helps with the carbon monoxide, the NOx, the hydrocarbons. We have scrubbers. Scrubbers are part of the coal burning power plants, and they help with that sulfur dioxide. And then we have electrostatic precipitators, which help with the particulate matter. Okay, so again, just kind of wrapping it all up, that yes, we have air pollution. Yes, there are consequences of air pollution, but then there are also solutions to air pollution as well. Okay, and so I got a couple practice multiple choice problems here for you. We'll just do, like I said, maybe kind of a few more of these, and then we'll kind of wrap things up. Okay, just make sure your brain's still working, and then we'll wrap things up and have a little break. So catalytic converters reduce which of the following pairs of pollutants in car exhaust? Let's see if you were just listening. It's been talked about a lot.
It's like we're seeing B here.
Okay, so B, yes, it does help with carbon monoxide. Which one's going to remove particulates? So which one was a solution that we talked about multiple times in today's? Which one will remove particulate from smokestacks?
Looking at, I see a B here.
Okay, good. B is the correct answer. So if you guessed B, pat yourself on the back. Good job. Okay, and then which one is going to help us reduce sulfur dioxide emissions? I talked about it back in primary pollutants and just on this last slide.
D.
D? Okay, wet scrubber units. Okay. Good job, guys. Okay, so just kind of, I'm going to wrap up my part here, just so you guys can have a little stretch break or restroom break or whatever you need to do before we start the next session. Just kind of, as you go through these pollutants, and pollution is going to be such a large portion of your exam. Make yourself a chart. I'm sure your teachers will give you, kind of a little outline to follow. If not, make yourself one. It's just make yourself a little spreadsheet. And like I said, make sure you know where it's coming from, why we need to worry about it. So kind of the who cares, the effects, the consequences, and then what are the solutions, kind of looking at the bright side of it. Don't forget about your daily videos on AP Classroom. Like I said, no one wants to sit down and watch all of them all day long. But if there's an area that you're weak on, go ahead and look through those. Those are great resources. I said this at the last study session. You guys have more resources at your fingertips now than any group of kids that have ever gone through the AP program have. There's so much support through AP Classroom, so much support through College Board, so much support through Advanced Kentucky, through your teachers. Take advantage of it, okay? Those progress checks on AP Classroom, if your teachers are assigning those are great ways to help you prep for the exam. And then, of course, there's always the old-fashioned book. You guys use those anymore, but those study guides and those AP exam prep books are good ways. But again, that pollution, hit it hard, guys. Make your flashcards, make your charts, do a little sit and get. A lot of it is memorize, but when you get to those secondary pollutants, kind of make sure you kind of go through that a little bit more, because as you can kind of tell from this presentation, there was some confusion about primary and secondary. Secondary has a little bit more consequences and a little more chemistry involved with it. Okay, so I'm going to kind of end here and kind of wrap up here with you guys here. And then let me go ahead and stop sharing and come back to you guys. Okay, and see if you guys have any questions for me or anything else. If not, that's kind of my part. And like I said, guys, I know it was a lot of sit and get and memorize, but that's just what you got to do with air pollution. So. Okay, we're good?
Yeah,
Okay.
I guess we are. I don't see any questions. I did post a question there. I thought they might try and answer. Sometimes with the free response questions, you get the option to say, suggest a solution or suggest legislation or something like that. And so I asked them, and I'll ask them again here, would it be ideal to suggest legislation to target secondary pollutants or primary pollutants?
Ooh, that would be a good question.
And so hopefully you guys took away from this, if you're going to do some sort of suggestion of legislation or emissions standards, you're going to probably target the primary pollutants, because you can find those and you can kind of, if I can use the word point source, you can kind of point those out. Where you probably are going to have a hard time passing legislation for secondary pollutants, because they require constituents, they require prerequisites in the atmosphere in order to get them. And so you're going to have a hard time reducing those. If you look at those criteria pollutants, the ones that were basically non-existent anymore, like lead, it's because it was a primary pollutant, and we passed legislation stopping the use of lead in gasoline. So think about that when you are trying to think about suggestions or something that's realistic. Okay.
Yeah, because you have to think too, those secondary pollutants wouldn't exist if it wasn't for the primary pollutants.
Right.
So.
All right, guys. It is almost 10:55 on my end. That's Eastern Standard Time. I don't know where you are, right? Henderson County's across the timeline, right?
Yeah. It's only 9:55 here, so I got it extra early.
So let's take a break, and we'll come back here, and I'll start at 11 o'clock. I'm going to post in the chat a link to a slide deck for Google Docs there. If you guys would click on it, make sure the link is live, and I have all my sharing, all of that stuff figured out on my Google end. I see some people, anonymous avatars joining now. Okay. But we'll come back and I'll start at 11 o'clock. Okay. So you guys take a bathroom break or grab something to drink or maybe coffee, wake up a little bit, and I'll start at 11 o'clock.
You want me to stop there? Okay.